Welcome to episode 7 of It's About Data, the podcast about data, analytics, AI, and whatever. It's with Matt Housley of Halfpipe Systems and Tony Baer of DB Insight. And this week, our topic is MCP, the Model Context Protocol. And our question is MCP the rest for the AI era? Take it away, Matt.
Tony, welcome. This week we are talking about something emerging and very exciting for everyone in the data and AI space, which is MCP. So maybe you could briefly explain what MCP is and some of the recent developments that make this very interesting in a kind of constellation of different standards that have emerged.
Yeah, well, it stands for Model Context Protocol. And in short, it's a very simple elevator pitch. You can say it one line. It's basically standardizing how models or complex processes connect to data. And there are some, amazing parallels with REST in terms of what they are trying to do, but there are some major differences with REST in how they do it, and for very good reason. The Model Context Protocol, as I said, basically, it provides really more of a framework. It's really not an API per se. It's a framework for how models connect to data. Whereas with REST, that was an API. Now, the issue there, the challenge there was also connecting to data. But there was, in the case of REST, that was a matter of, say, internet applications, connecting to data sources through a simple get, HTTP, GET protocol. Whereas with in the world of AI, this could be a hell of a lot more complicated. You could be, doing something as simple as a database query. You could be doing something that basically is more complex, as calling a model, some tool, or putting a specific prompt. And you also have to allow flexibility because this is being imagined in the era of generative AI and agents, which are autonomous, which should be able to, based on the scenario or specifically the context of the situation, and kind of consider that essentially the AI equivalent of transaction state. Based on the state of that situation, the agent decides to take a certain action if it's an autonomous agent. So of necessity, the Model Context Protocol really has to be more of a framework rather than basically a monolithic API. I mean, that's the short of it.
Yeah, and I'll tell you, I am very interested in the risks that this solves for. So you can kind of think of this from two different perspectives. So one is that it accelerates application development because I, as an engineer building an application around AI, am not reinventing the wheel. I'm not building my own RAG framework. I'm not building my own interface between agents and data. I just have a standard framework that should stand in the middle in principle. But what about the risks? Well, the risk with something like RAG initially is that you would query data to respond to a query. So for example, if you're using Perplexity or Google Search, in order to serve your request with the latest data, not just the old data that the model was trained on, you run a query, then you feed that as part of the prompt into the model so it can use that data to build out the response. Well, what's the problem with that? Well, you have major risks of data leakage, right? If you're using RAG and you're connecting it to sensitive data, if you're not very careful, then that query that comes in could generate a call to the data that pulls in stuff that it's not supposed to, and then that gets leaked out into the response. And one of the ideas in principle with MCP is that you're building a standardized framework that should protect against some of those risks because you're building in a standardized way of handling security. With agents, all of this gets amplified even more because with RAG, you're typically using code of some sort to issue the call. So code hopefully can be built in a robust way so that it's not going to access the wrong data. You have access controls. In some cases with agents, they were just letting agents directly query the database with nothing in between, build SQL queries and such. High risk. And so what I'm excited with personally with MCP is that we now have a standardized way of doing access control and deciding what the model should actually have access to.
Well, the key there is that we have a standardized starting point.
Yes.
Standardized starting point does not necessarily mean it's automatically secure.
No, it doesn't.
And we're still early on. These are still early days. I mean, this thing was only announced like barely 6 months ago by
Yeah.
Anthropic as being open source. I read posts not from Anthropic, but from someone at AWS right before I went off to reInvent. And I remember writing a LinkedIn post saying, I hope we hear more about this. Well,
Yeah.
it was a little bit early to be hearing about that then. But the fact is that this basically framework was really just unleashed on us, as I said, barely 6 months ago. And they're now in an initial, in a new rev, they're adding some authentication, but, based on OAuth. So that's certainly a step forward. But there's still we're still early. You can't build Rome in a day. And so, for instance, right now, as I understand it, from the latest of what I've been reading, is that the server that does authentication and resource access is the same thing, which is fine if you have a very tightly coupled model, but that's exactly the opposite of really what we're doing in AI, and especially with agents, we have lots of moving parts and autonomous moving parts that can take different actions. So that's clearly a vulnerability. But again, this is not to attack the spec, as being inadequate. It's that this is early, and these are the type of typical teething problems that emerging specs or standards like this undergo. You first come out with a specification, then you figure out, okay, what are essentially, what are the vulnerabilities that need to be fixed?
Yeah. Yeah. And I said before the show that this reminded me of the situation in the early days of the internet, late 90s, early 2000s. Of course, by then, relational transactional databases had been around for a long time, but we were used to querying those from secure systems, right? Within corporations, one system would make a call through some middleware to another, to a database of some sort. So you weren't worried about outside attacks quite as much. Well, once you went on the web, you could have like a search box where you typed in a query. Then the code in principle was supposed to convert that into a SQL query. And hackers figured out pretty quickly that a lot of the code that was being used to generate those SQL queries was insecure. And you got what were called SQL injection attacks.
Right.
Sometimes they still happen. We're much better at that now. But one of the things that happened is we started moving from doing bespoke code to access SQL databases to using standardized libraries. And to your point, we didn't solve the problems overnight, right? It's not like every database access library was completely invulnerable to injection attacks immediately, but it meant that we could just work on those libraries instead of reinventing the wheel every time and creating new risks. And so that's what excites me about this as well, that if you have a standardized library, if you have many, many companies working on it, then in principle, we should be able to solve the security problems together and find new security problems together as well.
Yeah. Let's talk a little bit about like what this actually is, how it's really designed. I think that's really kind of to put some, perspective on this.
Yeah.
At the very top, you basically have three basic, sort of components or players in this. You have the client, which is really, which could be, it's your request. It connects, makes the request to the server, and that could be the agent, or it could be a human. You have the host, which is pretty much the model itself. And then you have the servers, and this is where all the goodies come. It's just basically where you get the access to the data. But that's also where you need to, at that tier of the architecture, you need to actually, obviously, have the security or the firewalls or whatever measures in place. Now let's kind of dive a layer beneath all that, which is that the logical architecture is, and this is a very good blog post that I read that gave a very core description of this, and I'd like to, afterwards, I'd like to put the link up to this blog. It's probably about the best explanation of MCP, but she described it as basically being 5 layers, under the hood. One is the model, and that's really the brains of all this. There's the runtime, which is the orchestration layer, because essentially this is not like a REST, call where you're doing a simple GET request to a database or a data source. You have then what they call the tool, and that tool could be, it's the stuff that does things, which could be a tool, could be an API that leads to some other APIs. For instance, that's where, for instance, you can invoke, say, GraphQL or something like that. That's the secret and the beauty of the flexibility of MCP, is that you have that flexibility at that tooling level. And then 2 other really critical components that I think really, this is called Model Context Protocol. and that context is there for a reason, which is that it has an in-memory cache in a sense, but it's more than just a cache. But this is where essentially it's storing really the state of the whole of the whole interaction, and
so history and such, for example.
Exactly. So so it's not that the model is keeping state. It's that it's in this context layer where you're preserving the state, and it also knows has awareness of the underlying schema. All that wonderful stuff that comes that you can with for lineage, and also where you can use potentially for audit trails, which will probably be very important. Then the other part of all this is why I say this is not why I view this as a framework and not an API. Is that there's a schema, and that schema is not the schema of the data source, but it's to the messages that are sent from the client, to the server, and it's a specific, and it lays out, and it's laid out in a very strongly typed JSON schema that says that this is how you make these different types of requests to do these different things, and that's because there are lots of different types of tasks that you could be asking, that you could be requesting through MCP. So I'd say if I was to look at the real stars of this, it's really the memory that maintains the context, and this whole JSON message schema that allows the complexity and the flexibility. So that's how the thing works. That's really the secret to all this. It's pretty amazing stuff.
Yeah, and so in that sense, it does sound like an API. I guess maybe I'll bring this up now because we're getting toward the end of the show, and this is something we talked about. What is to prevent this from becoming a non-standard standard? And what I mean by that is that MCP, like you were saying, is maybe more of a framework, and you have to build integrations that work according to the MCP standard. One of the problems with REST, which you brought up, is that it's not really a standard, right? Like every REST API is kind of different. It's in principle it is, but they all work somewhat differently. The verbs really don't give you that much. Like you have to know the details of the API to know how to communicate with it. Another example that I throw out a lot, being in data, is SQL. So there's something called ANSI SQL, right? Which is supposed to be the standardized version of SQL. But the reality is that if you take a query for Teradata, say that's ANSI, and you try to run it on Oracle, it won't work. Like if you try to take a query for BigQuery and run it on Snowflake, it doesn't work. Like it really, ANSI SQL is like this whole, it's again kind of a framework. Like here are things that you can do to be ANSI compliant, but they're actually, what they've ended up doing is just adding more and more different versions of vendor SQL to the quote unquote standard. And so I can't think of any two databases that are really compatible where you don't have to translate something. So I hope that this doesn't turn into the same kind of situation where it's so flexible that you kind of have to fudge everything every time you're developing an application.
Matt, I'm just so shocked to be hearing this about SQL database. I thought there was just this one standard.
It's magic standard.
You've just ruined the whole last 30 years of my life. But seriously, I think the real question here, or the real, right now at this point, and I don't have the names off the top of my head, but there are a bunch of like really minor sort of point little protocols out there that, very, very, single purpose type things. I think more of the question is, why should any players spend time on reinventing the wheel here? There's really, in itself, there's no value added. And in a sense, that's kind of the same thing behind, for instance, the open table formats in the Lakehouse, which is that, and even Databricks has decided it's not worth having to compete here. It's that there's basically no value add in a table format. It's just a means to an end. And so for that matter, I just don't, the fact is that, all the vendors in this space, whether they're developing frontier models, they're developing domain models, they're developing, the consulting services, they're, developing ecosystems, they have, or they're trying to get compute power. There are a lot more, basically, much bigger fires are, on their, I don't know if let's go the fires on their plate. That's a really mixed metaphor, but but there's a lot more on their plate. And the fact is that having to compete on a protocol on how you connect it, to data sources is just, it'd be an interesting research project. But now that Anthropic has put something out there for any other vendor, like at this point, why?
And I can think of two reasons that might merit that eventually. Although right now, I think you're right. Like I think we're just going to see more and more consolidation for the moment. But the two major reasons are, one, if Anthropic becomes too restrictive as a vendor. In other words, if they have so much control over the code base and other companies that want to use this say, hey, I'm not able to submit my requests into the spec things I need in it. Anthropic is like really kind of choking the spec, and maybe they're doing things internally that aren't compatible with it. We've seen that again and again recently. In fact, that's part of the reason you talked about Databricks. That's part of the reason that Delta never took off. Like, yes, in principle, it's open source, but they didn't really play nice with others. And so if Anthropic got to that point, then I could see other companies saying, you know what, we're going to join our own coalition and build something new that's not under Anthropic's control. And the next reason is that standards can become obsoleted very quickly if there's some limitation that people discover. So think, back in the data world, Apache Hive a few years ago, like all the rage in the Hadoop ecosystem. I'm sure it's still running out there, but no one talks about Apache Hive anymore because it was just too limited. And so they all moved on to Apache Spark and Presto and Trino and these other standards. And so same thing, if there's some core limitation of the way the spec is designed, then people could decide to either fork it or just completely build something new instead. So it's going to be interesting to watch because, like you said, it's quickly emerging as a standard, but we're only 6 months in, right? So is it really a standard or not? Like, what will we be talking about 1 year from now? Maybe I need to make a note on the calendar, return to this discussion then.
Yeah, I think you've hit the nail on the head there, which is basically if you see an Apache community type approach here, I would say that's probably more likely, but it's also that versus the fact of this stuff is a fast moving target.
Exactly. Yeah. And another example I'll throw out there is Apache Airflow, right? Like very leading edge on orchestration. Now, I wouldn't call it obsolete, but there were certainly some limitations to how it was built that make it awkward for certain use cases, which led to other competitors to emerge. So same thing. Will it turn out that something that Anthropic did here was short-sighted, that they really needed to design the spec a different way? In 1 year, let's ask that question.
Sounds good. Okay, I'll see you here this time next year.
Okay, sounds good. It's a date.
Sounds good. Good talking.
Yeah, great. All right. See you next week, if not sooner.
Okay.
Take care.